So, all right, guys, good evening once again. Now, today, we will be continuing from where we left off yesterday. So we are on the topic of coordinate geometry. And we had gone through some things that we can do with straight lines based on coordinate geometry. So we had done those yesterday. But today we are going to be looking at linear equations. Now, as I had mentioned before from yesterday, linear equations are equations. When you plot them on a graph, you get a straight line. Another name for linear equation would be simple equation. Now, there are certain characteristics with linear equation that you have to become familiar with, right? So I'm going to go back to the equations that we started looking at yesterday. So we say that most of the linear equations that you'll be coming across will have the general form of these equations that are presented here. All right, now, except for the last equation, where you notice that in the last equation, you have x and y variables on the left-hand side of the equation, but in all the other equations, you find that you only have y by itself on the left-hand side of the equation. Now, when you have the linear equation in that form where y is by itself on the left-hand side, now that's a general form that we call the y-intercept form, right? Now, in the y-intercept form, you always start with y by itself on the left-hand side. So for this last equation, which is not in that form, you can actually make it in that form by rearranging the terms in this equation. Just like when you're solving an equation, you move everything onto the other side of the equation and try to leave the y by itself. So you treat it like when you're solving. So I'm going to rearrange the last one so that it looks like the others with the y on the left-hand side. So to do that, we are focusing on keeping the y on the left-hand side. So whatever y value that we have on the left-hand side, we want to keep it on that side. So the 2x, we will move to the other side because we don't want the 2x on the left-hand side. So if we do that, we follow the same general rule that if we move a term from one side of the equation to the next side, we change the sign. So the 2x is positive on the left and you bring it on the right-hand side, then it's going to become now, it's going to become a negative 2x. Now I'm going to write it before the 5. So we have negative 2x. And the reason why I put it before the 5, because I want it to appear like the ones that we have up here with the x in the first term on the right side. So we would have negative 2x plus 5 when we move the 2x to the right side. But now on the left side, we still have a 3 beside the y. We don't want that 3 beside the y. The 3 is multiplying the y. So what we do is to do the opposite. By using the 3 to divide both sides, we will get rid of the 3 from the left-hand side. So if we divide the left-hand side by 3, remember now, anything you do with one side of an equation, you do the same thing with the other side. Now we could divide it this way and divide the entire expression. And so we would get y is equal to all of this on the right-hand side. But because we really want it in term form, we want the terms to be separated. So what we can do then, we can, sorry, it's supposed to be 3. So what we can do then is to divide each term in the numerator by 3. Instead of writing everything over 3, we put each of the term in the numerator by 3. That means you would have negative 2x over 3 plus 5 over 3. Now, writing it in this way, you will see now that it is closely resemble the forms that are up here with these 3 that we have. Now, for this one would be still in this form, but we could rearrange this and put the negative 2x in front the 6. So we would, instead of having 6 minus 2x, we would actually have minus 2x plus 6. All right. And so this one would now resemble the first 2 that we have. And so when they're all looking in this way, we say that they're in the general form. So what is a general form? Now the general form is written as y equal mx plus c. So what it means? It means that there's a number that represented by m, and there's a number which is represented by c. When you look on the left, this equation on this side, you see that the number in front, the x here, would be 3. So if you compare it with the general form, then this m would be equal to 3 in this equation, right? And this last term here, 7, would be equal to c, right? So the c in the general form would take the place of the 7, right? If we look at the next one, we see that the 4 would be the same as the m in the general form. And the c now would be minus 5 for the general form. So once you look at all of them, you should be able to compare them to the general form. So from all of them, you should be able to say what m is and what c is when you look at them. Once they are written in the form where y is in the left-hand side by itself, or on the left-hand side by itself, and another meaning to that is that y is the subject. So when an unknown is by itself on one side of the equation, we say that that unknown is the subject of the equation. So in the general form, y is the subject. All right. Now, we looked at yesterday's class, we were looking at how to find gradient. Now, this m is actually the gradient of the line that the equation represents. All right, so m in the general form represents the gradient of the line. All right, so we would just put GRAD for short, for gradient. All right, now C is what we refer to as our y-intercept. And the intercept is just where it cuts the y-axis. So the value at where the graph cuts the y-axis is known as the y-intercept. And it is the value that you get by itself in the equation. So this 7 is the y-intercept. And this 7 here means that the line cuts the y-axis at 7 on the y-axis, at positive 7. This one means that the line cuts the y-axis at negative 7 on the y-axis. All right, so is that clear to everyone? Raise your hand if you're following, guys. Ms. Waysam, are you there?
Yes, sir.
Are you following? Is it clear to you, Mr. Adams? I know you have missed out some amount of this topic already, but do you understand what I've explained so far?
Yeah, I'm seeing what's taking place. I'm not 100%, but I'll grasp it once it continues.
All right, so now just follow my direction and hopefully you will get some clarity as we go along. All right, so I'm going to clear all that I have here now. I saw Miss Darty had dropped off just a couple of minutes ago, and I see now she's coming back on. So I'm going to leave the screen for her to view before I clear it. Miss Darty, are you back with us now? Miss Darty, are you hearing us? Or should I say, Miss Darty, are you hearing me? Are you there? Well, I'm not sure what is happening, but she seemed to be having some internet issue. All right, so we'll have to move on. All right, now, so I'm going to clear what we have here. So as I was saying now, for linear equation, they're of this general form. Another thing about linear equation that you should know is that the variables would be the unknowns. So we have the y variable and the x variable. Now the power of these variables in linear equation, they are to the power 1. Now, when anything is raised to the power 1, we don't normally put the 1 above there, because if you raise a number to the power 1, it still remains the same number. So, but just to somewhat clarify, so if you don't see any power above them, or any number at all, if you don't see a power, there's always an invisible one. That means in that form, it is to the power 1. So any number that doesn't have any obvious power above it, they are all raised to the power 1. Now for straight line equations or linear equations, the x and y would not have any obvious power above them. So it means that they would be raised to the power 1. Is that clear to you guys? Now, that is an indicator. Just by looking at the equation and you see where the x and y variables are raised to the power 1, you should immediately know that if you plot that equation on a graph, it will give you a straight line, right? Because that is one of the properties of equations that give straight line. The variables must have the power 1. The x and y variables will be raised to the power 1. All right, so with that said, moving on. So now are all linear equations so these are all linear equations. Now the equation of a straight line is really what we are referring to. So all of these are equations of a straight line, so we call them linear equation. Now recall also that we may use an equation. Recall also that we may use an equation to plot the coordinates of a straight line. And we would have done that when we were looking at graph. Now, remember that in order to use the equation to plot the straight line, we would have been given some values for x from one range to another. So we could get x from -3 to x equal to between -3 and x equal to say +5 or +6. So it means that range of values for X would start from -3 go all the way up to +6. And generally what we do is we have a calculation table, right? So we tabulate all of these X values. We put the X values in the first row, and then we put the various parts of the equation in the rows that follow. So we would put 3x in one row, 7 or +7 in the other row, and the last row we would put in y. And so we would use the equation to calculate the x and y. Well, we would have given the x coordinates, so we would use it to calculate the y coordinates. And once we have the x and y coordinates, we use those to plot our points, and we would get a straight line. So all of that we have done already in graph. All right, so I'm just recapping that. All right, so so in the first instance, we use the equation to plot a line, or plot the coordinates of a line, and then we draw the line. But let's say now that we know the coordinates of the line. Would we know some coordinates of the line? Would we now be able to use those coordinates to find the equation of the line? And so that's what we'll be doing in this, at least in this section of coordinate geometry. We'll be looking at how to use what we know based on the coordinates, based on the gradient, based on the y-intercept, which is C, to get our straight line equation. So we are using the coordinates to find our equations. All right. So in other words, we are pretty much reversing the process of when we use the equation to plot coordinates. Now we're using the coordinates to find equation. All right. So now, we had looked at the general form of straight line. So we have y equal mx plus c. So this general form, you should remember it. Or in other words, memorize it, because it's a form that you will need when you're working with linear equations in coordinate geometry. So you need to remember this equation. So make this equation commit to memory. All right, so we know the general form of straight line equation, and we can now look at different parts. So the x and y of the equation, we refer to those as variables. Now we know that we have m. M is the gradient of the line. And from yesterday, we look at how to find the gradient of a line if we are given 2 points. So in order to find the equation of the line, we need to be able to find the gradient from any given points. We also know the C would be the y-intercept, which would be the point on the y-axis that the line cuts the y-axis. All right, so you just read the value from the y-axis wherever the line cuts the y-axis. So you can be given a line drawn on a graph and you don't know the equation, but just by calculating its gradient and looking for where it cuts the y-axis, you can now put whatever value you calculate for the gradient or whatever value you see on the y-axis where it cuts the y-axis, you actually can plug it in this general form where m is and where c is. You put in those values, and there you go. You get the equation for that line. All right, so it can be done just as simple as that. That is when you're using the line on a graph. But sometimes you're not given the line on a graph, but instead you are given points on the line. So you should be able to use the points, at least 2 points you are given most of the time, but you should be able to use those 2 points to calculate the gradient, because we would have looked at that from previous class. So you should have used you should be able to use the points to calculate the gradient, And you should now, after you calculate the gradient, be able to calculate C. And then once you find M and C, then you put them in this general form to get the equation. Is that clear, guys? Do you understand what I'm saying?
Yes, sir.
Okay. So every linear equation may be written in the general form, right? And I had given you an example that if it is not in the general form, meaning that the y is not by itself on the left-hand side, you can rearrange it as I did with the previous equation in the previous slide. You can rearrange it and get the y by itself because it is not in the general form unless the y is by itself. Is that clear, guys? So every linear equation may be written in the general form. Now, to find the equation of a straight line, we need the following. So either we need 1 point and the gradient. So if we know 1 point and we know the gradient, we can calculate the value for C, and then we can plug the value for C and M in the general form to get the equation. Or if we are given 2 points, we can use the same 2 points to calculate the gradient, and we can use the same 2 points to help us to find C. And then we can plug those values in the general form and we get the equation. Or we can use a straight line from a graph. So when you have a straight line from on the graph, what you want, in order to find C, you look at where the line cuts the graph or cuts the y-axis, and you take that value to be C, and you plug it in this equation. And then now you can use a straight line and you can find the gradient. Now, to find the gradient of a line, when you have it on a graph, what you need to do is to simply construct a right angle triangle to it. You find the length of the base in terms of x. You find the height of the leg of the triangle in terms of y, and gradient, which is m, would be equal to y divided by x. So if you have the line on a graph, this is how you find m. So you construct a right angle triangle to it, you calculate the length of the x, calculate the length of the y, and then you use this equation to find m, which is the gradient. So what it means that with a straight line, you can look for where the line cuts the y-axis and you will find C, and you can use the construction of right angle triangle to that straight line, find the x value of the base of the triangle, find the y value of the leg of the triangle, put those values in this, and then you get m. And so you would know what m